Yeah. Welcome everybody to the CC Colloquium. Today, it's my pleasure to have the chance to introduce Frank Timmies. I first met Frank in the early 2000s. Uh, some of you know that I'm from Los Alamos, and he was a group leader there for a while. They had a great astrophysics group going. Patrick Young was part of it at the time, and so when I would visit family, I try to make a stop over for a couple days and visit that group, and really appreciate the hospitality, from that time. And some good projects came out of that. I thought they were good projects.
I thought they were good. They were good.
And then I was, and then in 2007, I believe, was the year that Frank was hired here. It was the same year that I was hired, along with Patrick was also hired, and Arjun. And it's great to have him as a colleague ever since. So that's been great too. Frank is an expert in stars, their evolution, and especially their end states, when they go boom, often at the end of their lives. So he's an astrophysicist in the most literal sense. And he's also an expert in computation. And also he's, does a very CCS thing, which is apply his core knowledge in all kinds of different ways. He has collaborations with nuclear physicists and done a lot of astrobiology, studying like how these elements get delivered to different environments. And he's also a co-author of Mesa, which is one of the most widely used stellar evolution codes. And I think that'll be the focus of his talk. And he's done a lot for the community as well. He was a former ran the high performance computing here at ASU. He is now the associate editor. So I forget exactly the title, but he is one of the main editors for the AAS journals, which are our big journals that we publish a lot of astrophysics in. And I won't embarrass him. He has many of awards and prizes that he's won, but I won't try to recreate a list and embarrass him. But rather, I turn it over to him to talk about some of the great work he's doing with Mesa.
Well, thank you, Evan. Thank you. Everybody hear me? Front and back? Okay. We begin. Tomorrow will be the celebration of the 10th anniversary of Marston Theater, tomorrow at 10 o'clock, and I highly encourage you to come and show your support of Marston Theater. And the reason I'm showing this is because I am also celebrating an anniversary. And that anniversary has to do with the Mesa project. So, quick audience poll so I know tune this talk a little bit. I want you to raise your hand if you don't use any software at all in your research. Okay. I want you to raise your hand if you don't know what Mesa is. Don't be shy. Okay, good. Everybody knows what software is. And in the second one, this talk's for you. Okay, we're going to talk a little bit about Mesa. So let's start off really global. Stars are great. I think they're really great. Gravitationally confined thermonuclear reactors. Okay, but mainly what my research is about, broadly defined. But we'll just start off with a very global. Stars are great, really great. Okay, and since stars are great, we need good models of them. That just sort of follows logically, yeah? And so what is Mesa? Mesa is a software instrument that models the evolution of stars. And Mesa does stand for something. Mesa stands for Modules for Experiments in Stellar Astrophysics. Doesn't have anything to do with Phoenix or Tempe or anything like that, okay? So that's what Mesa does. It evolves models of stars. And did I say stars? What I meant to say was single and binary stars. It can do planets too. Neptunes and up, hot Jupiters. It can do explosions. It can take stars and make them pulsate. Very interesting. And it can do a whole lot more. Okay? And at the very core of Mesa, the heart of Mesa, is a set of software modules that can be used by other people, or they can be combined to solve the coupled 1D stellar evolution equations with an implicit finite volume P. This gorgeous picture right here is one row of a matrix showing the first derivative, the Jacobian matrix. And that is as technical as I'm going to get in this talk. Okay? I'm mainly talking about the Mesa project. Okay? So Mesa is a set of software modules, and there's larger projects on top of that. And the description of Mesa, the capabilities of Mesa, the description of the Mesa project has been described in 6 what we call instrument papers. The first one came out in 2011, when the clock starts. Okay? Mesa 2 in 2013, Mesa 3 in 2015, Mesa 4 in 2018, Mesa 5 in 2019, and just submitted, it's under review right now at the Astrophysics Journal Supplement, 6 in 2000. Okay. So each one of these instrument papers is about 50 journal pages long. Okay, they are substantial pieces of work. Okay? And even the fact that there is 6 of them is an innovation. If you've ever worked on a software project or done something of that nature, there's usually one software paper that introduces the topic, introduces a software instrument, and that's it. You never hear from the software instrument again. Maybe a decade later, they'll put out a second instrument paper. And everybody who works on software knows that by the time the paper is published, it's out of date. The software has already moved on. And so this innovation of multiple instrument papers tracking the progress as we go through has been an innovation. Okay? And how are we doing on that innovation? How are we doing on those 6 instrument papers? How is the community responding to those? Okay. So this is the Bibliometrics for Mesa project. I'm going to focus your attention on the inner histogram at first, running from 2011 when Mesa 1 first came out, all the way up to 2021. And although it is only October of 2022, I decided to put the 2022 metrics on there because they are already exceeding 2021. This should be a banner year for citations for Mesa, a decade plus after the initial one came out. The success of the Mesa instrument papers is in the upper left there. Mesa 1 is one of the top 5 most cited astronomy and astrophysics papers that was published in 2011. Mesa 2 is a top 10. Mesa 3 is a top 5. Mesa 4 is a top 10. Mesa 5, top 15, and rising. In 2022, we don't know about because it's still under review with the journals. So if you take those citations and you sum them all up, you get 7,401. Pretty sparkly number. Okay. But that's just people who are using Mesa. What might be more interesting is to take one step back and ask, well, what about the larger science community? Okay. How do they value the science papers that use Mesa? Okay. Those papers, 2,902 of them that use Mesa and cite Mesa, have been cited 170,000 times. So there's sort of a citation multiplier of about 20 between direct citations and one level out. In other words, the science that is produced by Mesa is valued by the larger community, not just an insular small community publishing itself. That's the bibliometrics for Mesa. Who are these people? Okay. Well, these people are distributed around the globe. Mesa has had a global impact on research in stars. Get to that in a bit. As you can see, we are global. We have an active, engaged, registered community of about 1,100 in 2022. Since 2021, there's roughly double that because every year about 10% of the people go out, postdocs move on, they change fields, etc., and you get a new crop coming in. And so cumulative, it's been about 2,000 over the past decade. And Mesa has a dominant share of the available market. Okay. There's only so many places in the world that will need studies of stars, and we've saturated. So when I remake this plot for 2023, I do it every year. Whenever you make this plot, those pins aren't going to move. There's not going to be any new pins. The market is saturated. And roughly at least 50% of the literature dealing with stars uses Mesa. And when people start putting job ads out that say Mesa experience desired, okay, then you know you're having an impact. Okay. But these thousands of users are supported by a much smaller group of people, okay? And so Mesa takes a village to operate. Okay. I have probably played all of these roles at some level. I have been in there. I would say a lot of my time has been spent that character over there looking at the metrics. How's Mesa doing? How are we going? How are we going to make it better? What's the scratching head? You will also notice that this light is battery powered. That means the battery has to be replaced every now and then. And we're going to talk about that. Okay. So I think me personally, I'm going to be moving back over into one of those battery guys who operate on battery. Okay. So there's Mesa. There's a group of people, Mesa developers, that take care of Mesa. But Mesa itself is also just one part of a much larger software ecosystem that operates between what we do on Earth, laboratory astrophysics, where I've listed here some nuclear facilities, laser facilities, big electric jolt facilities, and high pressure facilities, which we do really well here at CC. And a sea of software to get to what you see on the sky, okay? Whether that be gravitational waves with LVK, or whether it's neutrinos with Super Conde or Conde with gadolinium, all those instruments. So this software ecosystem operates between what happens on the Earth and what happens in the sky. And Mesa is a prime driver of many of its partnerships. Okay. That's Mesa. That's it in a nutshell on what Mesa is, what it does, what kind of an impact it's had over the last, depending how you count, 12 to 18 years. And speaking of those 18 years, I would like to talk a little bit about the past, and I will take it all the way up until January 2022. We'll call that the past. Okay. And so we'll talk about it. And when I mean the past, I mean really the past. I'm talking December 8th, 1968. Okay, where there was a demonstration given called the mother of all demos. I'm going to be silent for 15 seconds, and I want you to read that. I want you to read that. That's a quote from Wikipedia on the mother of all demos. I want you to read it. Invented the computer mouse. Anyone who thinks Overleaf to write your documents is some newfangled thing, I want you to read the last item on that list again. That's what Overleaf is. Okay. So this stuff has been around since 1968. The intellectual fountainhead of all this development was a Stanford professor called Doug Engelbart. In this image, Doug is in San Francisco, and he is delivering the mother of all demos. This is a live shot from the mother of all demos. It's about an hour long. In Palo Alto, down the road, was a graduate student by the name of Bill Paxton. And Bill is interacting with Doug as they go. So I guess for every Alexander Graham Bell, there has to be a Watson. Okay. What Bill was doing. Notice that beard. You're going to see that repeatedly. Okay. So that's Bill. And so Bill graduated in computer science from Stanford, and then he went and did a little stint at Xerox Palo Alto Research Center. And in 1983, he became one of the creators of Adobe. Yeah, I mean, Photoshop Adobe, Illustrator Adobe, Fonts Adobe, that Adobe. And what Bill did is Bill helped invent scalable font technology, vector fonts, type 1 fonts. Okay? And the public-facing part of this invention at the time was called PostScript, which then evolved into today's PDF. I bet every single person in this room has touched a PDF today. And if you have, a little bit of Bill is reaching out and touching you. And my point there is that it's really hard to get away from Bill Paxton. You have to try to get away from him. Okay? So Bill, after his fantastic invention, launched Adobe. Bill retired from Adobe in 1990 after 7 years. And he did what you might do if you had a big wad of Adobe cash or stock as it's moving through. So, you mark off things on your Bitbucket list, okay, with his wife. So I'll pick the story up again when I get this very unusual email in 2005. Hello, my name is Bill Paxton. May I please use the tools posted on your website? So 2 things struck me about this email. Number 1 is that it was coming from UC Santa Barbara, okay, the Cobley Institute for Theoretical Physics, where one of my colleagues there is Lars Bildston. And second of all, this message was unbelievably polite. People don't ask if they can download stuff off your website. They just go to it, download it, click go, and you do what you do. So it struck me that, okay, coming from Santa Barbara, it's unbelievably pleasant. This must be a grad. Lars has a new grad student. Yay. So I reply in kind. Well, about 3 emails later, I'm going, you are not a graduate student. Who are you? Well, a little bit of digging didn't take too long to figure it out. Was, oh boy, got a ringer going here. Okay? And so that's Bill circa 2005. And if he looks like a South Park character, so be it. Okay. And so Bill was Mesa's first author, and he was a senior fellow at computational astrophysics at KITT in Santa Barbara. I do know I'm using past tense here, and I will come back to that. Okay. Aware. That was my first interaction with Bill. It was in 2005. So by 2010, Stellar Revolution software instruments were usually closed source, closed knowledge, secret handshake, knew the right person, and it was concentrated in about 10 places around the world. And yet stellar astronomy was, and still is, booming with new telescopes, new missions, new puzzles to solve, new science to do. And so there was this huge pent-up demand in 2010 for new stellar models. And so by 2010, Mesa as an instrument was ready for release, but we pulled back and we thought about what if the possibility hit that Mesa was actually successful? What would that look like? What are we doing? How are we going about this? And it was going to possibly be a success because it was going to democratize stellar evolution. Instead of being at 10 places, anybody, anywhere could run a stellar model. And so the manifestation of these plans, of these ideas on how to move forward, was instantiated in the Mesa 1 instrument paper. And to this day, it remains the only paper published in the Astrophysical Journal that has an appendix whose title is Manifesto. Okay? Where we lay down what we're going to do with this software instrument, and I call your attention to the blue. It's going to be open for everybody. It's open source. It's open knowledge, and we hope that it will grow into a community research. Yeah? A manifesto. And by and large, we hit that pretty right, looking back on it 12 years later. And one of the things that we did in the manifesto, and to help build the audience, build your user base, build your customers for Mesa, was to conduct summer schools, building your next generation. And so the annual Mesa Summer School offered a week boot camp of hands-on labs to gain familiarity with Mesa and how to make better use of Mesa in your research. Okay, because that was the important part. So here are a number of, they have just gotten their graduation certificates. And they are rather happy about having survived a week long of Mesa Summer School. Okay. And this cadre, the reason we're doing this is because this cadre of instructors, of TAs, and participants, which are now over 500 people have participated in the Mesa Summer School, over across about 80 institutions, are now creating their own Mesa infrastructure at their own place, putting on their own Mesa Summer School, teaching their students how to use Mesa. Okay. Here is some of the demographics of Mesa from when we ran the first summer school in 2012 to the most recent one in 2022. The astute ones will note there's in the 2020 for obvious reasons. Okay. And we covered the entire gauntlet from graduate students to postdocs, undergrads, faculty, because they're good multipliers. Their students will use it. And even amateur astronomers participated. And that's just some of our demographics. Overall, we were hitting roughly 40, and it was limited on purpose. It wasn't like we were gonna have 200, but roughly 40, 45 per year. As you saw from the map, a lot of the activity in stellar astrophysics takes place in Europe, less so in the States. So it's not surprising on those demographics that a lot of the participants were non-USA. And as far as the gender goes, we were definitely above. You can get off the IOP website for Institute of Physics website for women at various careers. So we're pleased about that. Okay. And I just like this figure a lot because there's a lot of happy, shiny people here. Even Bill in the middle is smiling. Okay, that's a miracle. Bill is smiling. Wow, it does happen. I'm there in the front in the white shirt, down low. And I will call your attention just to person here. I'm going to call your attention to ex-ASU undergraduate student Carl Fields, flashing the peace sign here because you're going to see something that we built in a little bit. Okay. Tiny, happy people. That's a dream. Okay. So time went on. Let's see where I'm at. Yeah. So time went on, and the community built. The bibliometrics kept increasing. It just became obvious that Mesa was having a serious impact in the community. And so Bill, still with his beard, in 2021 was awarded one of the major prizes of the American Astronomical Society, the Beatrice M. Tinsley Prize, for his work that has seeped into the foundation of research. And then lightning struck out of the blue. Mesa makes an appearance in the Hollywood movie Don't Look Up. Okay, so I'm going to play this clip, and to be fair play, it's only 8 seconds long. Of course, it's in a smaller format. Okay, and you're going to hear the main protagonist speak, and that's Randall. So they're in this coffee shop, and they're going to be looking because they're talking about peer review, and they're talking about this article, and they're going to show this article. Okay, and so the clip, because it is clipped, you're not going to hear him say the first part of the sentence here. What you're going to hear, and I'm going to loop the movie, is you'll hear him pick it up from here. And Lisa Inez is where you'll hear the sound pick up from when I play this. Okay.
Mesmerizing on their team. I mean, this is next generation cutting edge technology. Mesmerizing on their team. I mean, this is next generation cutting edge technology. Mesmerizing on their team. I mean, this is next generation cutting edge technology. Mesmerizing on their team. I mean, this is next generation cutting edge technology.
And if there is any doubt that that figure is Mesa, there it is. This is figure 4 from Mesa 3. Okay. And I really like the fact that, Randall there is when he comes onto the Mesa shots, this is cutting edge technology. Yes, fantastic. mean, I jumped out of my chair when I saw this. I couldn't believe it. It was like, where did this come from? Fortunately, I wasn't first. So Jared Goldberg at Santa Barbara caught it first, that it was Mesa. And as it turned out, it was Amy Mainzer, who's just down the road at Tucson. And Amy was the science advisor for Don't Look Up. And so she took her job seriously. She created this report on exactly why Mesa was in something that's talking about asteroid deflection. That doesn't make any sense. That's the point. So it was put in to make it a nonsense report, because all the words here are things you might expect if you're trying to do a dart, right? Get into an asteroid, or you're trying to move something. And then on top, there's a stellar evolution plot. It's like, that doesn't make any sense. And that's the point. So we thank Amy for putting Mesa in the movies. It's great. Okay. That's the past. Now I want to cover the future, or the present. Where are we at? So as I mentioned, a thriving open software instrument takes a village to do. And of these characters in white, a number of them, this is in Mesa developers. So there's our world map. These are a number of people who are in Mesa developers who take an active role in developing the code, testing the code, interacting with users, and so on. Yay, Mesa users. Mesa developers. Okay. And so what do the Mesa developers do? Well, one of the things they do is they test often. This is continuous integration. Okay, this is your testing framework in your continuous integration. I won't spend too long on this plot, but so we have the year here on the x-axis. The material in white here are version numbers of Mesa. So this is version 10,000 versus 10,398, all the way up to version 15,140, when there was a tsunami change, where we shifted from SVN on Assembler to using Git on GitHub. That was a major transition. And we went through that pretty smoothly. So the number I want to poke on your head there is 1.4 million tests have been done across a variety of architectures, across a variety of different types of machines. So Mesa gets tested every night by many machines and many configurations. The other thing that Mesa developers do is they make Mesa easy to use. That's critical. You don't want your software instrument, you don't want your tool to be hard to use. So we make it as easy as possible. We provide a software development kit that contains everything you need to build Mesa. Because sometimes, you know, you pull down a code and, oh, I need this library over here. Oh, I need this library over here. Oh, I have the wrong version of this library. Now I need, what a nightmare. We take care of all that. Okay? All in the software development kit. We also provide OS level virtualizations, i.e. Docker, okay, so that you can run on any architecture. Hey, Windows. And you can also run older versions of Mesa with age-appropriate compilers, libraries, and operating. And that's bit for bit across all supported architectures. If that bit for bit doesn't impress you, good. Okay. So make Mesa easy to use. Get Mesa in the classroom. Okay. That is a major driver at this point. And so Mesa Web is a GUI, the cloud-based resource for education and research that has served up about 10,000 stellar and planetary models to about 1,000 learners over about the last 5 years of operation. This is one of the things that Carl Fields did. I pointed Carl out in that picture. So Carl single-handedly instantiated the first versions of Mesa Web and got it running. Learned how to use Slurm, and invoke Slurm, and just did the whole 9 yards. Got it all up. It was very, very impressive. Okay. It is no longer at ASU. It's now at University of Madison, University of Wisconsin-Madison. We'll talk about that later. But it was started at ASU, and that's pretty cool. Okay. And so another part of that is active support of your community. So once you go ahead and do all these summer schools and you're trying to get your users up and you're going, you got to support them. They're going to have questions, anything from newbie questions to, you know, senior researchers asking questions. And so we operate a very active listserv email that has served up about 25,000 emails over the past 11 years. We also have a Zenodo-backed portal because we want people to share. It's open knowledge. So if you do a paper, you do an article, we hope and expect and sometimes push that you take your Mesa-related material and you put it on Zenodo. Science 101, so somebody else can replicate your work, verify your work. Okay? And we also do direct support, of course, of graduate students and postdocs. And I have two of them here. One of them is CC graduate student Morgan Chidesker, and she is using Mesa to explore white dwarf seismology. And this lovely article was published less than 2 months ago, so this one is fresh off the kiln on trap mode. Variable white dwarfs as probe to the C12 alpha gamma reaction. Nice piece of work. Also, CC graduate student Eve Barrage is using Mesa to explore neutrinos and black holes from stars. This one just came out yesterday. This one finally went through. We got published yesterday, resolving the peak of the black hole mass spectrum. Very nice. Very nice. That's Morgan and Eve, grad students here at CC. And now in the remaining couple of minutes, I want to cover the future. So Mesa is not a startup anymore. That was a decade ago. And there are things that you do when you have a startup that maybe you don't do when your project is in a little bit more mature of a state. So I used to say that when Mesa started that I wanted Mesa to last 40 years. That was my goal. I've taken it through 11 of them, 29 to go. And in some sense, I equate a software instrument like Mesa to a hardware instrument like this ESO telescope at La Silla, 1.52 meters. Okay. The telescope is built. Now you need astronomers to come and put their eyeballs or their equipment at the back and use the telescope. And it's the same way with Mesa. It's built. Now what I got to do is just keep it going and have users use it, okay? Because it has a tremendous amount of capability. People leave, people move on. And so one of the issues right now facing going forward is a departure of talent. Bill has retired. Bill retired last year for the second time in his life, first from Adobe, next from Mesa. So Bill is retired. Some of our key postdocs have left. Waymo at Google pays a lot better. It's also easier to get a job. And so people leave for all kinds of reasons. And we are facing that now as we've had a definite departure of talent, and we need to address that going forward. And funding of open source academic software project is always a fun game. Okay? First of all, you always have to reinvent yourself, always, because they are like venture capitalist startups. They're looking for the bright, shiny new thing. Maintaining old things. Ew, who wants to take care of a road? Let's build a new road. Yeah, let's build a new road. Take care of the old road? Not so much. Okay. So the first time I tried to get funding for Mesa was in 2011, and I failed. And then an interested party came up and whispered into my ear, we don't care about your source code. We don't care about your code. And I was like, my mouth dropped open. It's like, what? But we might care about your community. The light bulb went on. Okay? Don't market your code. Nobody cares. They might care about your community. Okay? So market your community, market people, not a thing. Okay? So once that lesson was finally drilled into my head, in 2013, we picked up $500K for 3 years from NSF to begin the building process, and picked it up again in 2017, where we got a larger framework award to push Mesa into its current positioning. And each one of these had lessons. You want to mark it, quantify your metrics. I didn't put those I didn't just make up those bibliometrics right now for you. Okay, I've been making those bibliometrics for 10 years. Okay, I'm the guy on the needle watching, recording, and everything. Quantifying brand, because then it makes writing the proposal easy. You've got an enormous amount of data you can throw at people like, whoa, okay, about your project. Okay. And the third lesson is no island stands alone. Mesa may be great, but it's just one. So you want to be part of an ecosystem. You got to build your larger ecosystem. And hence my plot where we go from laboratory astrophysics on the ground to telescopes. That's the lesson. 2022 is a TBD. We shall see where we go here in the few remaining months before we go into 20. Okay. So the directions ahead going forward, these are going to be set by features that are going to be useful to Mesa users, advances in physics modules, equations of states, capacities, reactions, whatever it may be, algorithmic developments. One of the most recent ones is described in Mesa 6 is auto differentiation. That's a trick. That's an algorithmic development, and architectural evolution. Machines change, and you've got to stay on top of the changing machines, And with that, I want to thank you for your time and attention, and I'll take any questions you may have. Stars are great.
You handle the room ones, and I'll handle the online. Anybody in the room have a question? Oh.
Can you hear me? Yeah.
Yeah.
I was very surprised by the fact that you can model both stars and planets, because so is it different modules that like model different types of physics, or
Nope.
Is
It's all the same equations. It's all the same physics. What changes in a planet is things like materials, like you might have a gaseous outside on, let's say, a rocky core, if you were building a super Neptune, let's say. But all of that resides in the equation state. You have a rock equation state, you have a gas equation state, but you're still solving the same equation.
But you have equations of states over the whole range of pressure and temperatures of planets as
Okay,
well?
that's a bit over the entire. So, no. Depends what you mean by over the entire range. Can we do an Earth? No, we can't do it. Okay, but there have been many, many publications of people doing hot Jupiters and sub-Neptunes and things along those. Leslie Rogers, for example, is a big driver of using Mesa first.
So would you say the community is like 80% stars and then the rest, or how would you divide the community?
Ooh, that is so hard. Wow. I have to think about that, because it depends what you mean by star, right? What you mean by planet a little bit, and within the publication. I mean, obviously, on a planet, one burning is not. But within the publication, sometimes it's hard to split that a little bit, because a lot of times, like in tests, for example, what you're observing is the star, right? You have to turn that into a planet. So when you report it, is that really about the star, or is that really about the planet? How do you want to call that? Right? So it's ambiguous sometimes. So I'm a little hesitant to say 80-20 or 50-50.
Okay, thank you.
Yeah.
Yeah, I have a couple online here. Have there been any offers to privatize Mesa, or have private competitors arisen?
We still have after 11 years, we have no competitors to date. Okay. There are still the 1011 codes out there that are still usually closed source. Definitely nothing supported like Mesa is supported. So we have no competitors out there. And if somebody is asking about privatization, I would ask them to please come and talk to me and bring your checkbook.
There's a second one also. It's about education. How has Mesa Web enhanced or improved science education in the classroom?
Okay, because Usually in a stellar evolution course, you have a textbook and you work out approximate problems that you can do analytically in your assignments. You get a very broad brush view of how stars operate. So what Mesa allows, Mesa Web in particular, is instead of just writing twiddles and pressure, goes as 1 over density, you can actually do a model. You can actually do a live model within 30, 40 minutes, have those results delivered to you, complete with a movie of the evolution as it goes through. And so it makes education in the classroom of stars come alive. Students can actually run a model. And you can talk about whatever you want to talk about. But it's a fundamentally enabling capability that has not been there before. Okay.
This is kind of related to the previous question about planets, but is Mesa primarily used for like individual objects like stars themselves or like hot Jupiter's planets, or can it be used to model like the evolution of systems around stars as well, like protoplanetary disks, that sort of evolution?
No, so we don't do disks. So Mesa is a 1D, and I will give a very spirited defensive 1D if you like. But no, Mesa is 1D, so it's not going to do an equatorial disk, things along those lines. But Mesa does have binary capability, and there are people who publish where you have a star and you have a planet, right? And how does the irradiation from that star puff up to Jupiter, let's say? That definitely has been done. You can also do 2 binary planets going around if you like. I can't call anybody doing that, but it is possible to do. Is that good? Okay.
As far as using the program for education goes, I'm assuming a lot of the educators using this program resides in colleges, but I'm wondering if you know of any instances of high school Earth and space teachers using this program to get these ideas across to people at a younger age.
Not yet. But this is also where the future is going. So I'll talk about a little bit of the past tense. So that Mesa 2022 summer school in Santa Barbara is probably the last one. That's it. And there's many drivers for that, one of which I mentioned. Mesa is no longer a startup. The reason why we did those summer schools was to build user base. And so after 10 years of 40 plus a person and seeing the impact of Mesa Web on education, I now want to take that bigger at scale. And so the big push of the next couple of years is going to be to get Mesa in the classroom as part of both the high school or education. So yeah, that's definitely the direction we're headed. Coming up with modules so you don't have to think about how to show the students this. Yeah. Yep.
Sorry, Frank, I'm not going to ask a question, but I was just going to help answer the planetary question.
Oh yeah, please do.
So I know that there's a growing user base of people who like to model planetary sized bodies in Mesa. And I can only imagine that the capability will evolve and increase in its capacity. If you had your own equation of state for solid objects, that you could import that into Mesa and do it yourself. And I just want to say that Mesa is very modifiable. That's why it's such a useful code. So if you wanted to do a disk model, you could actually couple a disk model to a Mesa model theoretically and evolve something in 1D that had the effects of a disk tied to it. And there are people who have done stuff like that, like a star forming from a disk on a pre-main sequence. So it's possible, and the code is very malleable. So you can actually modify it in any way you want to get what you want out of it. So it's not like it's a one size fits all kind of approach. So yeah, you can do what you want with it. That's it.
So for example, if you don't like the gravitational constant, you can change it. And don't laugh, people do this. They do this as, what maybe G was different a long time ago, or maybe you have some mysterious scalar field that couples to gravity that reduces it over time. People have published with this stuff by doing this kind of modification. Yep.
Well, Steve Ruff says stars are great, but I'm biased towards planets. What is the estimate of the earliest planet formation, and was Mesa used to obtain that estimate?
If I understand the question correctly, it's asking when was like the first article published of using
Yeah,
a planet?
He's asking it as, what is the estimate for the earliest planet formation, and was Mesa used to obtain that estimate?
So you mean the earliest evolution in the planet? I don't know the answer to that off the top of my head. I would have to follow up on that one. No matter which way the question's meant.
Yeah, I was a little curious how that community came together in the early days. So Bill Paxton is brilliant and a great guy, but I don't think it's like community builder, right? So like, how did that sort of coalesce in terms of that manifesto and launching out?
Yeah,
Mesa?
yeah. Well, like I said, it takes a village, and yeah, Bill had certain strengths, and one of those was a coding strength. Some of his other skill sets, perhaps lacked a little bit, I would say. And so this is where other people come in. And so when Bill settled in Santa Barbara to retire. And somehow I don't know how, but somehow he got in his head that he wanted to do stars. Where that came from, because, well, I know, because stars are great, that's how. And so he first approached Lars about wanting to do something. Who are you? And so then, as you saw, Bill contacted me in 2005 because I had some pieces. And it was just sort of an organic growth among those first three, really, that just then started growing out. Lars provided the cover, the physical cover, of being at the KITP and exposing Bill to a bunch of people, and other people took on different tasks of community building, this kind of stuff. So in the beginning, it was a very organic process, knowing you're doing a startup. So everybody has different goals. You certainly don't want three people who are all coders to be in charge. That's not how you run a project. That is a terrible idea. You might need three coders, but then you need people doing other aspects, the business aspects, the advertising aspects, all those things associated with getting a startup to go. So, organically. And just to give you an example of what it means to mature, right? Because there are times when you're a startup, you can just sort of make decisions by fiat, right? Like, okay, this is what we're going to do. Boom. And you go. It's time to go. Let's move. And as you grow, as you get more and more people involved, it becomes ever more important within that community to engage them in any sort of a decision process. Okay, and so that's a change from just, okay, we're going over here, bang, okay, now we're going to discuss it, it's a much bigger group, etc. And so this is just part of the growing pains of going from a startup to something that's a little bit more mature.
Do you have anything else online? No?
Okay.
Any other questions? If not, let's thank Frank once again for a very nice talk, and yeah.
Thank you.
Thank you.